I'm here to talk about something different. So that was, if you're not used to, don't know much about Gradle, or you do, and you wanted to know more about where we're going, what we've been doing, that kind of thing, Hans filled you in with that. This is a different kind of talk. I'm going to be talking about a very kind of specific aspect of Gradle. There's many different Gradle talks I could do, and if you're interested in more Gradle talks, you can go to gradleware.com. There's many listed on there from last year's Gradle Summit. There's 2 full days of talks coming up later this week at the Gradle Summit, so there's many things that could be said. I want to focus on a particular aspect tonight, talking about using Gradle to build a custom build platform. So that's some nice words. What does it mean? What are we talking about with the build platform? So I'm really talking about if you have a portfolio of builds. So more than Commons Lang, open source projects. Likely when you're in your workplace, you have many different things that you're building. There's going to be significant commonalities across those projects. Probably things that you like to do the same across all projects. They may be personal preferences. They may be driven by architecture that you have to work with, those kinds of things. There's also going to be significant differences between those projects. And this was something that we kind of tried to ignore a few years ago, this fact. We tried to pretend that everything was the same and we could build it the same way. And that building Java software in particular was a more or less solved problem if we just stayed within the lines. That didn't quite work out. If you have a portfolio of builds, you're going to have some kind of desire for consistency. You don't want to go around from project to project and have it be completely different. That's going to waste time onboarding and just going to make things generally chaotic. And the flip side of that is you need some control. If you don't have some control, then the tendency is going to be that things will become less consistent and change over time. There are other reasons for control. Sometimes there are compliance issues. Sometimes there are just some standards that need to be kept. Also, whenever you have scale, horizontal scale, you need automation. You cannot apply manual processes that worked with when you had 1 build to 10 builds. Right? So you need automation. So here's a few assertions that I'm going to make that are going to back up why the rest of the talk is important, I think, in the software industry. So very few real software projects are alike. Practices are evolving. The way we develop software is evolving and changing and will continue to. And also the tools are evolving. Probably a lot more of us are pushing to cloud deployment platforms. We're using different CI tools, using different tools at every level of the build, and this is going to continue to happen. Everything is changing. So projects from 2 years ago are different to projects from this year, and things are just not static. Modern automation has to be effective. It has to be personal. It has to be automated to your particular conditions. You have to automate to the nth degree and get everything done, which means fine-tuning it to the way that you work. It has to be ambitious, which is another way of saying the same thing. You have to automate everything, and pervasive everywhere. You can't get away with just automating the thing that your tool neatly allows you to automate. Or you need a tool that lets you automate a lot. And the side of this is that if you don't automate, you're going to be put out of business. Companies deliver software faster and faster now, and it is a real competitive advantage, more so now than it was even 12 months ago. Hans was talking about LinkedIn, and obviously that's a huge difference to their business, their ability to deliver that fast. So modern automation is very different to the kinds of build automation we were talking about 5 years ago, 10 years ago, maybe even 1 year ago. All right, so one of the innovations that happened in the build space and in the sort of software framework tooling space in general was this idea of convention over configuration. All right. And this was a real win. It was a bonus. It let us stop inventing the wheel. So we were able to go from having to have a set of scripts on a wiki somewhere in XML that we would copy into different XML files across different projects, and that's how we achieved standardization, that kind of thing. We were able to use a tool that had some out-of-the-box conventions, did a lot of the legwork for us. Right. You can probably piece together the tools I'm talking about here. It allowed greater collaboration. When you have conventions, things can make different parts or different tools can make assumptions about the way things work, and they can collaborate. There's another famous problem with tools that don't embrace conventions is that when you're stitching things together, you have to take control of all those stitching points. I want to use Jacoco with this build. I have to find the exact kind of XML that is going to plug into the way that I compile stuff, which might be different to the way that the person who posted that snippet compiles stuff, etc. But it's not the silver bullet. It didn't solve all our problems just embracing conventions, or at least in the conventions that we did embrace and the way we embraced them. So the other side is that when conventions are too rigid, they inhibit innovation and efficiency. And this is a little bit of the head in the sand approach. So that if what I need to do is outside of the conventions that my tool gives me, then I shouldn't be doing it. right? That's the stance that some people take, but that's just not how an effective way to run the business. You have requirements, you need to fulfill them. Tools, if they get in the way, need to be gotten out of the way. So what this leads to is abstraction inversion. If you can't make the tool do what you want, you build something on top of the tool working around the things it doesn't let you do. So this is the shell scripts hanging around the build, this kind of thing. And so what you ultimately need, conventions are good, rigid conventions are bad. You need conventions that are malleable and scalable. So whose conventions are we really talking about here? Gradle is a convention over configuration-based tool. That's kind of something we embrace at a core level. But the key difference is that we're embracing your conventions. Conventions are a first-class citizen, something that you're in control of. You might want to extend the conventions that Gradle comes with. So it might be perfectly fine for you to say that all our projects use checkstyle. That's an assertion we're going to make. We just want across the board that to happen. That's not something that Gradle can say about all Java projects in the world. Right, so you want to take our conventions, extend that, make that part of your world. You might want to replace general conventions. So one of the things that Gradle does, and like another tool out there, as a convention says that there is a main set of source in this project. It's the stuff that we're actually building and might have little bits of test stuff hanging off the side, but there's this main thing. That makes sense for 95, 98% of projects in the world. But there's some projects that doesn't make any sense for. They construct software in a different way, so they want to back out of that convention. They don't want to have to throw away the whole tool. It's just, I just don't want that convention. Let me do things the way I want. It's extending and being able to back down so it's scalable and malleable. So Gradle is a toolkit, fundamentally. We generally don't like to say Gradle is a framework. We think about it a bit differently. Gradle is a collection of tools like Ant. That's what Ant is. You get all these pieces and you stitch them together via reams of XML. That's how you do it. Unlike Ant, though, part of Gradle's toolkit are tools for standardization, reuse, and creating conventions. So we have plugins, plugin stacks, which I'll talk about briefly, and some other points here which I'm going to go into. So this is roughly the order of things I'm going to cover that really talk about why I'm making that assertion that Gradle allows you to build your own conventions. So the deep API, the kinds of things you can do with the Gradle API, configuration rules, a very important part of that, how plugins work, how easy it is to create a plugin, and init scripts, custom distributions, finally, to stitch it all together. And please remember, feel free to ask questions along the way. Okay, deep API. So the Gradle API can also be used for reflecting. All right, let's see, you beat me to it, Justin, but I'll come to the second. So if you think about Ant, Ant is fundamentally a write API. In that XML, I tell it, this is what I want you to do. The Gradle API is read-write. I can look at the model and see what has been specified, what's happening. I have a richer interaction with it. So one thing I might want to ask is, or in short it happens, how do I make sure that no one compiles against anything with this group? Anybody worked with Plexus? Anything from the Plexus family? Okay, so you might have wanted to do this at some point. Yeah. Another, how do I verify the existence? So this way we just have some dependencies we don't want. I just want to get them out of my world somehow. We'll see how we're going to do that. Here's a different kind of one. How do I verify the existence of a test task so that every single Gradle project in our enterprise or business has a test task, which really means I can check out any project, run Gradle test, that runs the tests. Whether it's a JavaScript project, Android project, Java, whatever it is. That's our convention. That I have to be able to check out the project, run Gradle test. If it passes, then we're all good. And I want to enforce that. If somebody tries to check in a project that doesn't have a test task, that's a failure, right? So do those kinds of things. So the first one, here are some Gradle build scripts. Now, if you've never seen a Gradle build script before, this is kind of the logical equivalent of your build.xml or your pom.xml. This is the description of telling Gradle what to do. Now, we're looking at something a little bit different here. We're looking at that read side of the API here. This block of code is getting involved in the dependency resolution process and checking what happened. All right, so this is some groovy code. That's the language we write Gradle build scripts in. So configurations are buckets of dependencies. You can think Maven scopes, if you like, or if you're coming from Ivy configuration, similar kind of concept. Now, get the compile bucket of dependencies. This incoming is just part of the API. I want to talk about the things that are coming in the dependencies. After you've gone and resolved all those dependencies, let me have a walk through them and see what happened. So here, this is where we're walking through. Give me all the resolved artifacts, everything that came in. So this is my dependencies plus my transitive dependencies. Is there anything that has this group? Right? These are the dependencies I don't want. I'm just using some Groovy here to say, give me all the things with that group. Right? If there was anything, then throw an exception. We're failing here. So as soon as we've done dependency resolution, if we find this condition, let's fail. So if we had this situation, so if I ran it like this, we'd be fine. We're just depending on commons lang. Commons lang doesn't depend on anything. Be OK. You would hope that Gradle would catch this case, of course. We have a first level dependency on something in our blacklist. Oh, let me just move that down a little bit. And that's relatively easy. If you know that you shouldn't be using that dependency, then you would hope nobody checks that in. But there are all kinds of backdoors for dependencies in the Java ecosystem, right? We have large dependency trees. We have surprising dependencies popping up all the time. So if you have a blacklist, if you have things that you don't want there, you should be taking some steps to make sure that doesn't happen. And this is one way to do that. OK, so the second example. So that's one small part of the dependency resolution API. I'm going to show some others as we're going on. But here's a different kind of reading of the model. So what we're saying now is that Gradle, after the project has been configured, so after you've gone and run all the build scripts and you know everything about the project now, have a look and see, are there any tasks with the name test? If there aren't, then game's over. So this is my enforcing that there is a test task here. So the idea here is not to give a bunch of kind of standard rules that you could apply. You have the model there to read and make of what you want. So the aim is to give access to the entire model. Question? Yes?
Yeah, in terms of...
So the question was, in terms of giving access, how much of the kind of Gradle internals access to? And I guess the question is, I mean, how much do you have access to, really? Yeah. So it's not everything. There is a kind of internal compartment within Gradle that the API is carefully designed and expose the things that are safe, that are stable, that we can kind of expose in a safe way. Over time, we open that up to different kinds of things and very use case driven. So there is no particular hook right now to do exactly what you want. So to get into that caching layer, that's not to say there won't be sometime in the future, and there almost certainly will be. It's just not something that is accessed now. There's another. Let me come back to that point just after this. So I've got two layers here talking about the way the API is structured. The simple concrete outer DSL layer, which is, if you've used Gradle, probably where you've been playing. You've been adding scripts, configuring how things compile, adding some dependencies, this kind of thing. This is what we call the DSL. This is targeted at developers who want to configure how the build works. Right? And design choices are made to keep that simple, to keep it very concrete. As you go down, things get more abstract, more complex, and the target here are really build and release engineers. So you need a bit more Gradle foo, a bit more background knowledge to make that work, and it's very much designed that way. There is a third level here, which are the Gradle internals, which you have access to but aren't API stable. So they change from version to version. So if you wanted to do what you want to do, you could do it via that mechanism, but there's no guarantee the next Gradle release won't break your code. Okay, so just to make one thing clear, what so far as having these rules local in one project, that's not very useful. We're going to see how we can get that logic out so we can apply it to multiple projects. Because we're having a platform here, we have a portfolio of builds we want to apply this to. We're going to get there. All right, so Gradle provides many ways to configure speculatively. What do I mean by this? Gradle can configure things that don't exist yet and may not exist. This is very important for doing things across projects where you don't have intimate knowledge of that project. I don't know if every project that we're going to build is a Java project. I don't know what kind of dependency management is going to be in place in different projects. So I need to do things speculatively based on characteristics. The other option is you copy and paste across all the places you need something, which doesn't work out very well. All right, so how do I configure all the test tasks to be as parallel as they can be? So here we have a Java project. Gradle Java project. Gradle Java projects come with support for running testng and JUnit tests out of the box. All I have to do is put my tests in source test Java and run it, and away we go. One of the things I can configure is to say that run these in parallel batches. Right? So start up 4 test processes, fan the work out, and get it done faster. And I do that by just setting this simple property on the test task. So that doesn't quite meet our requirements though, because it's very easy in Gradle to set up other types of tests. In this case, I've used the very descriptive name other test, but this could very easily be integration test, functional test, browser test, whatever you like. So you could have multiple sets of tests quite easily. And the requirement is that each of those sets of tests should be run in parallel. But as the builder release engineer, I want to say that in a way where I don't know if they're browser tests, I don't know if they're integration tests, just all of them do it. So the way we do that is via this rule. All the things of that type, go and do that configuration against them. All right, so the interesting thing about this, which I'll expand on a little bit more, is that it wouldn't be rated or here. All right, it applies to things that exist and things that are going to exist in the future, which is very important. Again, if you're speculating about projects, you don't know what's going to exist. So if I ran this, all you'd see is that it ran faster when I uncommented that code, as opposed to, because I have more than one core in my machine. So a very useful technique. How would you do this kind of thing in Ant? Say you had multiple compilation steps and you wanted to do the same thing for all of them. There are some black magic ways to get this done, but most likely you're going to copy-paste this across. Right? That's usually the simplest way. All right, so how do I configure all test tasks to be as parallel as they can be? Let's apply the same technique to say that it's not only compile dependencies I'm worried about, I don't want anything from Plexus to show up anywhere in my dependency list. What I mean by that is I don't want it to be a test dependency, an integration test dependency, a functional test dependency, whatever kinds of source I have going on. So we're using this all keyword here. Configurations is a container of different configurations, so different buckets of dependencies, and just all of them that exist now and in the future, apply this configuration to them. All is kind of like a keyword in this API for doing this kind of thing. So the difference here is that I had the previous one, I had a hard-coded compile here, and I was assuming there was going to be a set of compile dependencies here. If I ran this on a JavaScript project that doesn't have a compile configuration, that was going to blow up. Right? If I run this, not that version, if I run this version here on a JavaScript project that doesn't have a set of compile dependencies, everything's going to be fine. So this little example here is just to show this characteristic of liveness. So I have what we call in Gradle a domain object collection. It's a container of things that has this property that I can apply configuration to future elements and things based on characteristics. So it's just a little snippet of code. Just creating one of those things. This is not important. What I have now is a container of numbers. It contains 1 and 2. We can think about this like a Java list. Right? So we have a Java list here. I can spin off a separate list saying, give me all the things that match this criteria. So all the even numbers now in that list. Right? So I now have 2 lists. I go and check, okay, well, 2's in the even number set. Makes sense. Let me add something back to the original list. Right? So this is numbers. This is the original set here. And it's now available in my derived list. Right? So if you've done any closure, any Scala using sort of persistent data structures, this is a similar kind of thing. Totally Lazy has some similar stuff for Java. But the idea here is that this is really a specification of what I want, rather than a concrete set. It's unlikely that you'll be wanting to deal about even numbers and whatnot in a Gradle build, but hopefully that shows the kind of characteristic of liveness. And these things are everywhere in Gradle. Some of the things that we can deal with in this manner, the set of tasks in the project, the set of plugins, do something if the Java plugin is applied, and when it is. The set of configurations, we saw that with the dependency example. The repositories, as different dependency repositories are added, do something. We'll see that. The source sets, so there's a different bucket. As somebody adds some integration test source sets or some functional test source sets, go and pre-configure them in some way. Pre-add this dependency or do whatever it is. And we can actually get notified as dependencies are coming online, that kind of thing. So pretty much anywhere in Gradle where you have a collection of things, you can do this kind of thing with that collection. So we can do it with all the things that exist now and in the future. We can just do things when new things are added, and we can do things when things are removed, usually far less useful. So we tend to just build as we go, rather than break down. Okay, so just a another dependency management use case, and we could do a whole talk on the different parts of the dependency management API and things you could configure, but here's just some interesting cases that highlight some of those features. So what I want to do is implicitly replace a dependency globally. And this dependency shows up in my dependency tree no matter where it is, swap it with something else. This is quite a common thing to do for logging bindings. Right? I don't want SLF over JUL, I want over JCL or something like that. And you can either maintain a massive list of excludes and deal with that, or you can just specify a rule and say, when you see that, just swap it. Dealing with fat jars is another example of this. Dealing with classified dependencies for different JVM versions is another example. But quite often the case, you just want to swap something out. And another example we'll have a look at is semantic version aware conflict resolution. So what does that look like? Here's the first one. So we're using the dependency management API here. We're getting hold of this resolution strategy object, which has a bunch of knobs that we can turn to configure how dependency management works. Here we're saying that, let me run some code. Let me look at each dependency as it comes flying past in the resolution process. All right, so here's a callback, and we get this dependency resolve details object, which has some API for looking at what was that went past. So here we're saying that if the dependency that went past was called Groovy all, right, this is the Groovy runtime library. If it's the all version, which is the fat jar, I don't want that. Instead, use the non-fat version here. All right, so I can just completely swap something out to anything I like. And there are a number of different ways to cut this, or things you could do with it. As I said, you could replace logging bindings, completely replace dependencies. A very common one these days is to want to hit some kind of web service to work out what this should be. So when I'm resolving dependencies, I want to use some kind of static notation that as things are going on, I'm going to get that dependency, ask some service, what should that be? So I can have a central manifest of how that works. There are implications of that approach. You now have moving targets and you're losing some repeatability, but for a lot of people who want to move fast, that's an option. So here's a different option. What we're doing now is the semantic version aware conflict resolution. So Gradle has automatic conflict resolution a la Maven with a few differences. So if I and my dependency tree depend on A and B, A depends on version 1 of C, B depends on version 2 of C, something's got to give here. We can't have version 1 of C and version 2 of C in the same project. All right, so somehow we have to resolve the situation. Gradle has a conflict resolution strategy called newest. So in that situation, it's going to pick 2.0 over 1.0, on the assumption that higher is better. You have all kinds of control over that. You could explicitly say, hey, no, I want 1.0 there, get rid of 2.0, all kind of ways to do that. But in the absence of other instruction, that's what's going to happen. Now, what you could do is say that, well, actually, we've got this whole kind of versioning thing under control. We strictly practice semantic versioning in our organization. And if you haven't heard of it, semantic versioning defines some very clear semantics about what version numbers mean. And for our case, what we need to know is that if a major version number changes, then that is no longer compatible. So if I wanted version 1.10 of something and I ended up with 2.2, that's not going to work. That change between 1 and 2 signifies that that is a breaking change. So in that case, using the newest is not really what I want. I want to say, well, we're in a bad situation here. I need to fix my code to not use 1.x. So I could actually, pretty simply, in these few lines of code here, implement that kind of conflict resolution in Gradle. So here we're saying, similar kind of thing, all dependencies, give me the thing that came in. We have the requested version. What did we ask for? And then what did we end up with after conflict resolution occurred? So we have the requested version and the selected version. All we're doing here is just parsing those version numbers out into a major minor patch, so into the kind of 3 numbers there. Just some little simple regexing here to break that out. Then all we do is just say that, well, if the major version number of what we requested is different to the major version number of what we ended up with, game's over. Right. I could also, again here, reach out to some database. Has this dependency been blacklisted? Has it passed QA? All these kinds of conditions. So Gradle as a tool can't anticipate all the possible use cases you might have in dependency management. What it can do is give you the levers that you need to implement your own solutions. All right. So we've seen some things you can do with the API. Now I want to package that stuff up and reuse it. Yes, question?
So with the amount of magic that I'm seeing, it is amazing. It's part of the DSL. If I were coming at this fresh, would I be able to dig in with a debug option or something that would just show the dependency management rules that are being applied?
So the question was, I guess, around discovery. So if I'm coming to this fresh and I wanted to understand what was going on, is there some kind of debug option that you could use to find out what was going on, essentially? Is that a fair summation? Okay, so yes to a point, I guess, is my answer. So the authoritative description of what's happening, of course, is the code, right? But if you want to see how that affects the end result, right? So after all these rules were actually applied, then the way you would do that would be to run Gradle. Debug's going to give you a lot. So what you actually want to see is the dependency tree, right? So how did this all work out? So Gradle dependencies, oh, I'm in the wrong directory. So that's going to give me, after, as a textual representation of the dependency tree. That's okay. A large dependency tree that's going to get unwieldy very quickly. So another option is I could, well, what I'm interested in is how did this work out for, let's say, the Groovy all dependency, right? So I could say, well, let's say Gradle, what I want, instead of looking at all the dependencies, just give me some insight on the dependency that is Groovy. So now we've flipped around. Now we're not seeing the top of the graph down. We're seeing from that one dependency, Groovy, here, right? And seeing why was it included, right? It was included. We ended up with that version because it was selected by rule and conflict resolution, right? So it detected there was a custom rule in place and things changed there. As to what the implementation of the rule is, you then have to go back and look at the code kind of thing. And just to take that a bit further, what you could do, this is a relatively new feature. I think I got this name right. Daz, Adam, if you... No help, fair enough. We're a very supportive team. Okay, so I applied another plugin here. The project report plugin gives me a bunch of other options to get information out. That added the HTML dependency report task, which I ran. And now I want to open that guy up. Oops. Reports, project dependencies, what is it? Index. So now I get a HTML file which has all my dependencies in there. I can go through there. And the nice thing about this report is that I get the dependencies output here, my whole tree. If I want to see that dependency insight information, I click on one of these guys, and there it is. Right? So I can see both versions. That's 3 or 4 Gradle versions old. Now, just on that point before I finish, what this would mean for users, say you were doing something like this, right, which is our semantic version aware conflict resolution. As a build or release engineer and you're implementing this, you'd want to go out of your way to make sure that this was a reasonable error message to tell people what's going on. And you can use the richness of the API to include all the information about what happened in the error message, right? So you wanted this version, but you got this version, you can't have it because blah, 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 whatever. So there's discoverability for the build engineer and also discoverability for the developer. Okay, back to plugins. So plugins are just reusable build script code. One of the things about Gradle is that there isn't a huge divide between the build language and the plugin world. So plugins are just the same things we have in build scripts packaged up in a reusable fashion. So who here uses Maven? Who here has written a Maven plugin? That's a pretty high number. Okay, usually, there's far more people use Maven than ever write a Maven plugin. Lots of people would like to. They would like to be able to get it to do something it doesn't do. But that's a pretty heavy undertaking in a lot of cases. So one of the design goals of Gradle was to make the barrier, the cost of entry really low, so you can start to factor this stuff out. Okay, so what kind of things could you do with a plugin? Add new capabilities. You could write a plugin that adds support for, let's say, using Compass, the Ruby-based SAS CSS processor, that kind of thing. So that's adding a new capability, or supporting the Android build toolchain. That's a capability. Add new conventions. Use a plugin to say that we use check style and everything. Do a plugin to do that. And tighten existing conventions, which is an example of the check style one. But bear with me. Okay, adding new capabilities. That's a completely different talk. How would I write a plugin that adds support for JavaScript, etc.? What we're really interested in is how do I write a plugin that adds or extends conventions, which is what we're talking about here. So it may provide defaults. A default would be that we just use JUnit 4.10 across the board for testing, just get it going in every project. We don't want to have to manually specify it as a default. There are integration tests. So if I just put my Java files in source, integ test Java, everything works. I want that to be a default out of the box. Dependencies always come from our repository, so let's just go ahead and pre-configure that. And we have to build for 1.5, so we're going to enforce that all our code is built for 1.5. So it's just a selection of different requirements here. We're going to implement some plugins that provide these things and package them up and see how we can reuse that logic. There are two main ways to package plugins. So they can be scripts, just like the script files we've been dealing with so far, literally just files full of groovy code that we can reuse across different projects. Or we can go a bit more heavyweight. We can write them as a class. We can compile them. We can edit them in our IDE. We can test them. We can upload them to repositories, that kind of thing. So we're going to see both of those. So here I have just a Java project, and I want to use my get those features and standards we were just talking about on the previous slide into this project. Where is it? Okay, here I have a plugins directory. And here is the implementation of my plugin. Right, so we had a few requirements. One was that we use JUnit out of the box. Right, so go ahead and set that up for us. We have support integration tests out of the box. So this following code here is all we need to do to make that happen. Say there is now an integration test source set, and we get a lot of configuration already for that. But we want to go a bit further and say that all of the compile dependencies are also integration test compile dependencies. Our main class path, we want for our integration tests as well, similar for runtime. You might also want to say that our integration test class path is a superset of our test class path, but we're not saying that here. It's only a superset of the main class path. We may use a different testing engine, etc. And finally, here's our test task that says go ahead and run those tests. So that's all the configuration we need to actually make that happen. And we can stamp that out as many times as we like, however many kinds of batches of tests you like. Another requirement was that we always use Java 1.5. So here we had go just and configure that ready. But also, before we actually go and do any compilation, make sure that hasn't changed. Right, so that the user hasn't, so the person writing this build script hasn't gone and changed that to 1.7 or whatnot. So we're enforcing that standard. Set it up as a default, and because this is a hard requirement, we just cannot afford to ship software that doesn't work 1.5, etc. Go ahead and enforce that. The other one was to pre-configure the corporate repository. We actually need to go a little bit further and say no other repositories are actually allowed. Right, so here we use one of those callbacks because this guy is a container of repositories. We can say all the repositories that come along, run this code for them. If it's not a Maven repository or it's not the repository that we want, right, so it's not our corporate repository, just go ahead and print out this warning and then remove it. So we're not going to fail, we're just going to say, sorry, you can't use it using the main one. And go ahead and pre-populate that. So that's our implementation of our plugin, just written in a little script over to the side. How do we use it? Oops, not like that, like this. So from any build script, we can just say, bring in that other script. Right, factor that stuff into a little script on the side, bring it in. It's like a mix-in or an include mechanism. It's just there. So this is useful when these things are project local. This will be checked into the source tree, or you may have it on a shared kind of network file system, but that's becoming less and less trendy to do. So if you want to use this across projects, one option will be then to pull it from HTTP, a HTTP server. You can give it any HTTP URL, and it will go and get that file and use it from there. Obviously, you want to be in control of this URL and make sure that random people can't put rm-rf behind this thing. So, this is probably a bad idea, reaching out to the internet, but use with caution. And that will give us our defaults. It would configure JUnit for us, configure all the bits and pieces that we need to do there. Okay, so once we get past that point, another option, so that we call collectively called script plugins. We can pull them from a local file system, we can pull them from HTTP. If we want to go a bit further and say, well, let's build this thing as a jar, we want to have some dedicated build logic and compile it up and share it that way. So here we have a Gradle project, and it's a little hard to see, so let me zoom in. So we're just interested in this guy. So here's our Gradle project, here's our build.gradle file. We have the special build src directory here. And this is a kind of magic directory inside of Gradle build. Gradle will find this and say, this is an embedded Java project that provides build logic. Gradle will build this first and put its output on the build class path to be used. So inside here, go up. I've chosen to implement my plugin in Groovy. You could quite easily do this in Java. We've got that same logic. This code should look pretty familiar. I literally just copy and pasted it out of that script from before, but wrapped it up inside plugin class, Gradle plugin. And this is actually just an interface with one method called apply. There's no deep contract here. There's nothing really to do. It's just a container for your logic, somewhere to put it, somewhere we know how to call it. All right, so I'll copy paste my stuff in here. Here's my implementation of my plugin, largely the same. Inside source main Groovy. Now if I run this project, what I should see, where am I? So let me run, let's say, Gradle test. I need to update my examples. They're a little bit outdated. I've got some deprecation warnings here, but that's just because my examples are a little old. The first thing we're seeing here is Gradle building that build source project. It detected it, built it as a Java project, ran its tests, put the output jar onto the build class path to be used. So another part of that was we have this little resource file here, which is a descriptor of the plugin that says that the plugin with ID corporate is implemented by this class, which was our class, right? So we've given our plugin a little ID, just like apply plugin Java or apply plugin XYZ. We can now do, oops, if we're in the right directory, we can, I think. Apply plugin corporate. Right, so I've packaged it up, put it in a jar, put it on the class path. I ask for this plugin, Gradle looks at that file, loads it up. So I can give things cute little names. So now we're still project local though. Right, this build source directory is inside my particular project. I don't have a mechanism for sharing this yet. But this is a good way to incubate build logic, incubate plugins, right? It's a very fast development cycle. I change the file, I rebuild, it's there, ready to go. But if we want to go cross-project, we need to do something a little bit different. So fortunately, Gradle knows how to build Java projects, and our plugin is a Java project. So what we have now is two separate projects, a plugin project, which is a standalone Gradle build. We're no longer using the build source directory, but it has the same code. We have that same Groovy file in here. We changed the build script a little bit because we're saying that I want to use the version of Groovy that Gradle provides because I'm implementing my stuff in Groovy, and I'm also compiling against the Gradle API. I need that plugin class, I need the repositories, I need all that stuff, right? So it's a standalone Java project. I can put tests in here. Any of the Gradle-y stuff that you can do with a project I can do, including uploading it. So here's in Gradle how I configure where I want this project to go and upload. And in this case, I'm just going to upload it to the file system, treating the file system as a Maven repository here to share it. Question in the back.
Gradle API, is that, do we think of that as being a dependency or some kind of a magic name that's equivalent to a dependency? I'm used to seeing things like compile would it be just a specification of like an artifact.
Yep. So the question was, Gradle API, can we think about that as a dependency or a kind of magic name for a dependency? And probably the latter. It's something that's built into Gradle that says if you want to compile against a Gradle API, use that notation. We know what that means. We'll set things up.
Is there anything else that gets that special treatment?
This is the only other one saying give me the Groovy from. So the question was, is there anything else that gets that special treatment? Yeah, if you want to talk about, if you're building Gradle logic, it makes sense to just use Gradle's version of Groovy at build time. So you've got, so they're synced up. They're the only two that I can think of. I'm pretty sure that's the only two that exist. So of course, if we're building Gradle build logic, we need that stuff here. So here's my source main. There's my Groovy file that we saw before. My properties file is there. So let's go ahead and publish this guy. So I should be able to get out of this directory. Now I have my plugin and project. If I run Gradle, upload archives here. And if you haven't seen this before, When you're specifying the name of a task on the Gradle command line, you can abbreviate it, and Gradle will fill in the gaps. So the long version of this was upload archives, but I'm far too lazy for this, so I'm going to go with that. So go ahead and build that and push it out. Here's where it's pushed it to. Now this could very easily be HTTP, but for the sake of demo, I've just pushed it to the file system. And what I see now is, what do I see? In the wrong directory. So there's all my plugin files as a Maven repository on disk. And in my projects where I want to use this, I need a little bit more configuration to get this guy in, right? Because it's now in a Nexus or Artifactory repository somewhere. I need to get it onto my project, and this is how I do it. Saying that the dependencies I have for the build script, you can go and get them from here, and this is what they are. And this could be Commons Math, could be any library, any Java logic you want to use in your project. In this case, it is a Gradle plugin. If you'd like an alternative to this, stay tuned for later in the week. So now I've got that on the class path, I do the same thing, apply plugin corporate. And that would work. I should have listened to the instruction. Sorry about that. Okay, so one other important aspect of Gradle plugins, and this is really a really great feature, and you've used this. If you've used Gradle at all, you have used this feature. The ability to extend the DSL. You can inject your own language elements into the build files, and they look and feel like first-class elements. So this slide is probably should be updated, because probably for most people, the best example of this is the Android block in a Gradle build file. If you've built an Android project, you'll know that you specify all the things you need to do under this Android block. So Android, open up this thing here and use the API for that particular plugin right there. And it looks and feels like it's native to Gradle. Right? But that's an extension to the DSL that the Android plugin makes. It's going to want to make this new language element available, this new API, just inject it and make it available there. That's very easy to do. And this is something that many people who are using Gradle do. Build and release engineers use this to expose nice, concise DSLs that developers can use to make the build do all kinds of configuration under the hood. They just need to expose one or two little switches. When those switches are turned on, lots of things happen, but those switches get exposed via a nice little DSL. So let's see how easy that is to do. So our use case is that we don't really have just one repository for dependencies. We have multiple, and people have to select them. But we'd like a nicer way to do that. So here's how we could do it. So we're doing it all in our build script at the moment. Again, I could factor this out into a plugin or different classes, but for the sake of brevity, let's do it in one file here. I just wrote a simple class, simple Groovy or Java class with the API that I want and that has the functionality that I need. And here's the API that I want to expose. It has a use libs method. When somebody calls this, we go ahead and set up that particular repository. So I have my implementation here. Here's my DSL extension. In one line, I can inject that into the build script. I say that make this guy available under this name. So after we've done this, my build scripts, I can now go ahead and do this. And it looks like a first-class citizen in the build script. So if this was a way in a plugin somewhere, the user of the build script wouldn't have to know any of this stuff. All they know is that if I want to specify repositories I need, this is the syntax I use to do it. Corporate repos, whatever is in there. Another concept that you'll find throughout Gradle is this idea of plugin stacks. I mentioned at the start being able to opt out of conventions or back out. This is a key part of that. So sophisticated plugins like the Java plugin, the Android plugin, the native stuff, they're actually comprised of multiple plugins that stack on top of each other. And the Java plugin works like this. There is a base plugin. In Gradle, it provides some core functionality like clean, some core dependency management stuff. There's a Java-based plugin that gives us the ability to run tests, compile code, do these kinds of things. What it doesn't say is anything about the project. It doesn't be so bold as to say there will be main source and there will be test source. It just says that I know how to compile Java code if you need me to. The Java plugin goes further and says, well, thank you for that functionality, Java-based plugin, but I'm going to state that there is main source, there is test source. So the developer just puts their files into source main Java, source test Java, and it works. So here we have capability, so this guy, and here we have convention. So if those conventions don't work for you, you just drop down a level. And so instead of applying the Java plugin, let's apply the Java-based plugin, build our own conventions on top of that. All right, init scripts. So there were plugins, and one more point I want to make about plugins, just to reiterate, is that inside a plugin implementation, you can do exactly the same things you can do in a build script. There's really no special API that you use. All of that logic that we use and all the API I haven't seen is available to you. So if you've written a build script, you can write a Gradle plugin. There's really no difference there. Okay, init scripts facilitate cross-project configuration. They have a larger reach. They allow us to make statements about many projects, and they exist at a different point in the build lifecycle. They're really a bootstrapping mechanism for getting things going. And they, again, are just Gradle scripts, just the text files full of groovy code. And there are a few places we can put them that Gradle will look for them conventionally. So inside your user home directory, you'll find a little .gradle directory. So this is tilde/.gradle. That's where Gradle stores this dependency cache and a bunch of working files in there. You can go ahead and put an init.gradle file in there, and Gradle will implicitly look at this and run that every time it runs a build. So you might want to put something in there like, well, I've got a really fast machine here, I've got 8 cores, just go ahead and turn test parallelism on for all tests. We don't want to turn that on globally for every developer, because in some cases we don't like it, but on my machine, I want it. Or after the tests have run, if they failed, go ahead and just open up the HTML dependency report straight away. The other guy on my team doesn't like the behavior, I really like it, I'm going to set it up for my environment. Obviously, you don't want to do things here like, in my project, I'm going to change the dependency, so my version of this project, I'm going to change the version of this dependency from 1 to 2. Because obviously, when you build it, it's going to be different to the way that it builds in CI. But sort of behavioral differences of the way Gradle works and some logging and things like that. It's a good candidate for this. This is the same thing, just showing that you can have multiple of these files. The most interesting one in terms of the build platform idea is you can embed these things inside the Gradle distribution. So Gradle home here refers to a Gradle installation. So I can put files inside the Gradle installation and have them work. Just implicitly loaded. Therefore, every single project that runs with that Gradle installation is going to have that logic. And one other option that is typically only used at the CI server is to specify which init script I like. I can use -I, say use CI init.gradle. That might do some extra checking or some other configuration that you need in CI only. But the one we're most interested in is this guy. And before I get to why that's so useful or how that can be leveraged, I need to discuss another feature. No, we don't need to discuss this more. So, what can build scripts do? What can init scripts do? Load plugins. We can preload plugins. Specify plugin repositories, environmental configuration. More or less all the same things that plugins do, you can do it in init scripts. But they happen sooner. So they're generally used for a bootstrapping mechanism. There are certain listeners and things that you can also register in an init script. So you can have things happen before Gradle starts to load a project. So very, very early checks in the life cycle. Okay, so let's have a look at what would an init script look like that preloads a plugin. So here I have an init.gradle file, and it's just more groovy code, more Gradle DSL. Because an init script is global across many projects, we have to say what projects are we interested in. I'll use this API to say that just go ahead and run this code against all the projects that you load up. All right, so go ahead and just pre-seed that dependency information for our build logic, just get it going there because we always want it. So now when I build that, I could specify -I, point to the init script, put it in my user init.gradle. None of those options are really that appealing because it's not portable and it's not implicit. So, need to take it a little bit further. So out of the people using Gradle, who here is using the Gradle wrapper? Let me put it another way. Who is using Gradle and not using the Gradle wrapper? Okay. Didn't you put your hand up twice, Sean?
Yeah.
Mix and match. I like it. Okay, so what the Gradle wrapper is, I won't go into too much, but it's a self-bootstrapping build system. So let's have, it's a way the build system can self-bootstrap. So let's just have a look. That's not what I wanted. So I have an empty project here, nothing in here. I'm bootstrapping a new project. I'm the build master or release engineer. I have Gradle installed on my machine. I run Gradle init, which is a way to bootstrap a new project. Gradle init takes a few parameters. I can tell it that this is a Java library. So go ahead and set it up that way. I can say it's a Scala library, go ahead and set it up that way. It's a Groovy library, etc. You may know this kind of idea as archetypes in other realms, I guess. Okay, what I want to do is just give me a bare bones Gradle project. Go ahead and do that. So it's done two things. It's created a build.gradle file for me to kind of help me get going. A lot of stuff commented out, so you probably go ahead and do that or selectively take what you need. But more importantly for us, it has set up the Gradle wrapper. So this Gradle wrapper directory, we have the Gradle wrapper jar, which is how the thing bootstraps itself, and this properties file. So if you haven't seen this before, what happens now, once I have done this, I get these files which I check into the project. Here's a Gradle W shell script, here's a Gradle w.bat batch script for the Windows folk. And from this point on, I now run the build via these scripts. I no longer use Gradle on the command line, I use /Gradle W. That's going to load up, have a bit of a look around. And when I say load up, it's really this guy here, the Gradle wrapper jar. It's about 200K, I think last time I checked. Using this configuration file, it's going to work out where does Gradle get installed on this machine and where is Gradle if I need it to get it. So if it doesn't find Gradle in the place that it needs it, it's going to go and get it, install it, and use it. All right, so what that means is that if you're using the Gradle wrapper on a project, you check it out of source control, run the build via Gradle W. If it needs a version of Gradle installed, it will just get it and things are going there. So you have a completely portable build. So for bootstrapping, that's great. It's also great for version pinning. You know that the build is going to be run with the version of Gradle it was designed for. You don't have this mix match of you designed it for one version of a build system, person has a different version on their machine, all kind of chaos ensues there. It's a very useful feature, and it looks like almost all of you were using it, but if you know somebody who is using Gradle and isn't using the Gradle wrapper, they should be. Every single project should use the wrapper. Question, Sean?
I've had pushback on open source projects with the Gradle wrapper because they don't like people checking in the jars.
So the question, well, it's more of a statement than a question, but...
No, it is a question. Is there a solution to that?
Okay, so the question was, how do you deal with open source projects where the jar can't be checked in, or there's the desire not to check that small jar file in? There's no simple, easy, portable solution to this. So some enterprises who use this feature, they also have some restrictions against this. They have their own deployment tools for pushing out tools to machines, and they pre-seed machines with Gradle, that kind of thing. Obviously, in an open source project, you can't pre-seed open source development from around the world. So at the moment, your alternative is to say, well, go and install Gradle, basically. Yeah. Yes, Justin.
Sort of a leading question, I guess. Would we ever see the actual Gradle commands maybe respect the wrapper properties file so we don't need the jar?
So the question was, will we ever see the Gradle command, what we're using before, respects the wrapper file, or respect the jar, right?
Property file.
Property file, yes. So let's say that what I want to do is, I guess the end result there would be that instead of using Gradle W, you just use Gradle and have the same functionality exist, so that if Gradle wasn't installed, it would go and download itself, that kind of thing, right?
More respecting the version number that's in the property file, so that maybe on my path I have 112, but the project was locked down to 19.
Right, and it would stop, go and get 19, pass over control. There's no reason why you wouldn't see that. It's a really good idea. There are some solutions like that out there in terms of people who have taken the Gradle W scripts and packaged them up in a reusable way, and they push out a kind of modified version of the Gradle W script to machines. So everybody has Gradle installed, but it's not really Gradle. It's really the Gradle W script that kind of looks around. So that's the kind of workaround for that at the moment. But yeah, that's a good idea, and it should, yes. So question is, can you do it now? No. Is it a good idea? Yes. So you might be in the running for a book, we'll see. Okay, so the Gradle wrapper, that's a great standalone feature for single open source project builds, for portfolio builds, whatnot. But what I guess really interesting is that you can actually specify what part of the configuration of the wrapper is where should I get it from, right? The default version is go and get plain Gradle from our servers. All right, if you need it, go and download it from the Gradle.org website and install it, which is just the vanilla version of Gradle. There's nothing stopping you from changing this URL to pointing to a different version of Gradle, possibly modified version of Gradle. How would you want to modify Gradle? Well, you may want to patch the code if you're really ambitious. That's one option. Or you could go ahead and put an init script inside that distribution. Right, so this is basically, that zip is a packed version of Gradle Home. Unpack it, put your preceding init script in there, repackage it up, put it on your HTTP servers, and get projects started by pointing to that. Therefore, you have implicit logic that is custom to you, but you're guaranteed that every project uses it, or the project that needs it uses it. You don't have to go ahead and preload that information on everybody's machine. So it's a bootstrapping mechanism. And many people who do this go ahead and automate this process. So here's an example of a bunch of builds to go and do that, just for a bit of fun. So I've created a little Gradle project here, and what it does is it goes and downloads Gradle from our website, unpacks it, goes ahead and puts our init script in there, which is our init script from before. Go ahead and preload this stuff. Right? And we want to repackage it and upload it. So go ahead and download Gradle, because there's no kind of built-in download functionality at the time that I wrote this. I just wrote a quick little Gradle task to do this. So another Gradle, top of Gradle extension, I wrote a task, a bit of imperative logic to do some work. And it just uses the JDK to download the zip, write it to disk. So download it, unpack it. This is pulling apart that zip file, merging in our init scripts into the right directory, and here my emulation of uploading is just to copy it to another place on the file system. There's nothing stopping me from treating this like a jar that I just made and pushing it up to a Nexus or Artifactory if you want to, wherever you need to get it to. So I can automate this customization process to a large extent. So at the end of that, I get this thing built, and now what I would do in my project is wrapper enable this, change the URL to point to that custom uploaded version, and then I implicitly go ahead and get all that logic that was in the init script in that project. So that's the kind of current state of play. Of course, just keep in mind that the examples that I chose of things you can customize and things that you use the API for, they are selective examples. There are many more things you can potentially do. There are lots of aspects to the API. Typically, a good starting point, if you have a question of can I do this, forums.gradle.org. Go and post there. It's a public forum. The developers of Gradle, like myself, monitor that, and we help people out. Other Gradle users around the world do that. So if you have a kind of question, I want to do this thing, I don't really know where to start looking, post there. I usually get a pretty good answer. Okay, so where are we going with this kind of aspect of Gradle? And as I mentioned, it's one of many aspects of Gradle. So plugin development and lifecycle support. You can develop plugins now, you can release them, you can test them, but there's certain things we could be doing to make that easier. We definitely want to do that. And I'm sure Justin has some things he could say about that. Keep an eye on, Justin's going to be announcing some stuff later this week at the Gradle Summit. I'm sure that's going to be made public information, so keep an eye on that. Justin from Netflix. So plugin discovery and use infrastructure. As Gradle grows, it becomes more mainstream. There are more and more Gradle plugins appearing out there. And you might want to, has somebody written a Gradle plugin to do X, Y, Z? And there are several versions of that. Is there an open source plugin out there that does this? Has somebody else in my organization written a plugin that does this? Kind of thing. So discovery and use. What are the plugins being used in this build? If I'm getting all this implicit logic, I want to know about it. Third point here being richer plugin collaboration constructs. It's very easy to write plugins that collaborate in Gradle via the model because I can read and write and I can look and see when things have done, that kind of thing. Plugins can collaborate. We want to make that easier and richer. Basically allow deeper kinds of collaboration. So a good example of this, this is burgeoning in the Android space. We have the Google team producing the Android plugin, and there's been an explosion of test in the cloud providers come along. So you can basically take the Android plugin, take the plugin from this provider, and automatically now your tests go up and get run in the cloud. There are many, many aspects of this. So we have really rich collaboration going on between plugins. And that's, the Android realm is really pushing this. So we want to make that easier. And really make it, while it's not hard to create a custom distribution and use it, we want to make that simpler. We want to provide better tooling for managing that process. And what that really comes down to is make running Gradle in a context a first-class citizen, where the context may be your organization. And that may mean different things to running Gradle in the kind of open source world. Right. So that can all be done. We've seen examples how to do that, but we really want to make that a first-class concept, because it is important when you are creating a custom build platform to do that. So that's all we have time for. So we have a few minutes left and for some questions, and I see one at the back, so let's jump to that.
Are there tools to start migrating from Maven build straight across Gradle?
Yeah. So the question was, are there any tools to migrate from, is that another question or a question on this? Okay, I'll come back to you. So the question was, are there any tools to help migrate from Maven to Gradle? So what you can do, in the interest of time, I don't have a Maven build here ready to go, but what you can do is install Gradle on your machine, download Gradle, unpack it. You have to set a few environment variables ready to go, so to the point you can run Gradle. Go into your Maven project, your directory with your POM files, and if it's a multi-project, go to the top, run Gradle init. It will detect that that's a Maven build, detect the POM files, and convert them over to Gradle files. So the output of that result is a bunch of build.gradle files on your file system. Now what that's going to do is copy over the dependency information, compiler configuration, most of the 80% stuff. Things like the configuration of the Tomcat plugin, your assemblies, those kind of things, it's not going to catch those. But it does the grunt work for you. Right, and then you look at the plugins that you're using, the functionality, and find the equivalent of Gradle and fill in the gaps. It drastically speeds up the process. Typically, because Maven is so rigid in its structure, it's typically quite easy to convert a Maven build. If you have an Ant build that was designed 15 years ago, it's a different story. You know. The question was, does it include parent POMs that are outside of the project? If it can determine what that dependency is in terms of it's a it's a runtime dependency and not a configuration dependency, yes. But if it's like extra code, configuration code, no, you're going to have to deal with that somehow. Yeah. So, there's a question at the back.
Yeah, you mentioned types and types.
Yes.
How does that translate from the Maven?
So this init mechanism is the startings of that. So this bit of, let's say, init type, Java library, etc. This kind of templating system. At the moment, it's a closed set, and we haven't yet opened this mechanism specifying what type do you want, but that's what we're going to do. So basically a pluggable system for specifying your own types when you're running Gradle in your context. It'll know about your custom types and load that stuff up. Yeah. Sorry, at the front here. Feel what it was, yes.
Question for transition from Maven to Gradle.
Yes.
Also,
so the question was, converting from Maven to Gradle, really about how do you deal with the Maven site plugin, I guess is what it comes down to, right? Generating a website for your project from your Maven build. There isn't a direct equivalent that we provide, so that we don't provide a kind of Gradle site plugin. There are third-party ones out there that do a similar kind of job. They give you a place to put your Java docs and that kind of thing. They're all kind of loose ports. There are some that go a little bit further. Using GitHub Pages is now very much in vogue for open source projects, so there are plugins that automate that process and deal with the GitHub templating system, that kind of thing. So to the first part of your question, there is no direct translation, but the equivalent functionality is there in terms of third-party plugins. The second part, in terms of can you use Maven plugins from a Gradle build? Not in a kind of native way. You can't take a Maven plugin and plug it into a Gradle build. But what many people do in a transition is they put Gradle in front and have Maven do certain bits of functionality, right? So you can tell Gradle, hey, tell Maven to do this. Just run this Maven command, grab its outputs, take it a little bit further, do this kind of thing, and then eventually cut Maven out of the process. So there's no deep native integration, but there are mechanisms to keep the two running side by side for a time. This kind of project documentation space is pretty hot. There's lots of stuff going on, particularly around ASCII doc and some other tools to make this a lot easier. So yeah, that's kind of the state of where things are now. Over here. Okay, so the question is, myself and Hans use the term we quite a lot in talking about them things. Who is we? Yeah, fairly. So we, I'll speak for myself. We is the Gradle core development team, I guess, which are a bunch of people employed by Gradleware, which is the company behind Gradle, as full-time engineers, trainers, consultants, that kind of thing. Gradle is an open source project, and we run it truly as an open source project. We do design out in the open. We discuss with anybody who wants to discuss how things should be implemented in Gradle. We accept third-party contributions, all that kind of stuff of a normal open source project, but we have our commercial entity behind the project. Does that answer the question?
Can you expand just a little bit on that? So when you think of we, are you thinking of the open source aspect of it, or are you thinking of the company? How do I read that?
Okay, so again, I speak for myself, not necessarily Hans, but I'm an engineer on the project. So for me, we is Gradle, first and foremost, and that's all I'm really, how we want it to work, that kind of thing. And what we're really focused on is making Gradle a great tool, making it successful, and then people want it to work, that kind of thing. And what we're really focused on is making Gradle a great tool, making it successful, and then other people work out how to make money out of that, hopefully.
And then specifically, when you were talking about the we who makes the decision not to open this, is there the open source aspect of that that opens up the we a little bit?
So I don't quite understand the question. The question being, actually, can you just clarify a bit, and then I'll repeat it?
So you were talking about a specific example of the definition.
The internal API thing, yeah.
How to expand.
Okay, so...
We had decided not to open it yet. I was trying to decide what that meant.
Right, okay, so the question being that I mentioned a particular feature, and there was a question on, is it part of the API to do something with the dependency cache? Who is we in regards to the decision to not open that up yet? That's really the Gradle core engineering team. The decisions about what's in the public API versus what isn't are engineering driven. It's about making things public that we can keep stable and that are at a certain kind of level. That's really just a engineering decision. There's not really much of a business imperative behind that. There's a deep commitment to keeping Gradle an open source project. There is not a pro version of Gradle, a paid for version. You may see certain other things come along, but Gradle itself is fundamentally an open source project, and it's in its DNA how it works.
And what's the license model?
Apache 2. Yeah. Question at the back.
So maybe in regard to that, so when Luke says opening up, it's really just saying this is a public API where we promise backwards compatibility. Of course, the stuff that is not open up is also open source, but it's an internal API. So if you mess around with that, we don't guarantee that your extension that uses the internal API will work with the next version of Gradle. But you can do that. It's all open source. Right.
So just for the video, what Hans was saying is that, yeah, in terms of opening up, it doesn't mean that you can't access that stuff and you're closed off from it. It means that we don't consider it public, stable API that we encourage the use of. You can use all the internal stuff, but we don't guarantee it's not going to change from release to release. And many companies do this. They want that feature, they use it, they wear that change, but they understand that aspect of it. Sorry, question in the back, and I'll come over there. Yes?
Sure. One of the biggest indicators of a Gradle project is when you come across something that's in source main Java, right? So is this the recommended way when we start a new project? Should we convert existing projects from traditional source to this? Or is, it just some random thing that one of the early engineers said, oh, I like this, and stuff?
Okay, so the question is, the specific example was the default location of Java source in a Gradle build is source main Java. So if we're coming to Gradle from a different project, should we embrace that? Should we keep doing what we were doing? Why is it that way? That the question? Yeah, okay, so why is it that way? I wasn't around when that decision was made, but that's kind of what Maven did, and it's a reasonable default. So why not use it? There's no kind of greater alignment of the stars as to why it's source main Java, I don't think. The question is, should you use it? So should you change your project to use those defaults versus keep your custom setting? That's largely up to you. What many people do in a transition is leave the build the way it is, put Gradle in around it, get Gradle producing the same thing that the original build was doing, and test drive that. So as you're building out the Gradle build, you're writing tests to make sure that the jars are exactly the same between Gradle and whatever your previous build system was. So just get it in place and get it going. And then the difference between using a custom directory for your source versus a different one is probably, it's about maximum 2 lines of Gradle configuration code to say that. Now, if you're happy to wear those 2 lines, it's no problem for Gradle to do that. But it's generally, people will say, well, it's much of a muchness. I just want to get rid of those 2 lines, go with the default location, it's standard. let's go with it. Let's not have the hours-long argument about what we should call the directory with our Java source code in it. There are many things you should have those arguments about, but I would say the directory that you put your Java source in, probably not one of them. Over here.
Are there any tools that you recommend to help with scripts like completion, IE,
So the question is, are there any tools that we recommend to help write the build scripts, so IDE for code completion, etc.? The current state of the art is IntelliJ, IDEA. They push things forward with their content assist in authoring build files quite a lot, especially in IDEA 13. There's a long way to go, though. The Gradle DSL is very dynamic, as opposed to Java code, which is completely static. It's great for tooling. They can really understand a lot of it. The Gradle DSL is quite dynamic, so it's a big challenge for tools to auto-complete it. But that's, as Hans mentioned in his tooling point, this is something we're very keenly aware of. So it's something, and it's driven by Google Android folks as well. There's something that will improve drastically over the coming releases of Gradle. So the current state of the art is really IntelliJ IDEA. Eclipse has some support as well, but IDEA's kind of leapfrogged a little bit. And developing your custom build logic as a plugin, as a standalone Java project, is the way to get the best results. Because in that way, you're writing your code in just Java or Groovy files like it was a web application, rather than in build scripts, which are a little bit different. There's not as much hinting there for the IDE to deal with. So if you want editing support, develop it as a standalone project. Yes, at the front.
In the same way you have this way to convert a Maven build, Maven project to Gradle, do you have any automatic tools for going from, say, Gradle 1.12 to Gradle 2?
So the question was, in the same way that we have the ability to convert Maven builds to Gradle builds, is there a similar kind of tooling for moving between Gradle versions? There are no conversion functions out there. So you can't, so automatically changing your build script from 1.12 to 2.0. What we are building, have been for some time and will continue to do, is building some tooling to help you check between different versions. So to assert that when I move from this version to that version, everything is still the same, so that you can just move forward with confidence. But really, we take backwards compatibility extremely seriously. So if you're not moving across major version boundaries and you're not getting deprecation warnings, 99.9% of the time, you'll be able to upgrade just fine. Moving across major version boundaries, even then, is if you don't have any deprecation warnings, you're still going to be fine, right? So backwards compatibility is extremely important for us. As Hans mentioned, it's a very conservative domain, and we release every 8 or so weeks. Right, so you can't be rewriting your build scripts every 8 weeks. It has to keep working. So I'm very serious about that.
One last question we have to do.
Yep, sure. Let me get the front here.
Do you have an example of like how you go about the build flavors for a project, for example? And is there like a best approach to follow? Like right now, I have a scenario where I have like 2 different source folders for 2 different build flavors. Is there like a better option than that? Because for example, I might have a scenario where I have to check and code to the both flavors at the same time and make sure so that's error prone. So is there a better approach?
Okay, so Android-specific question. So the Android build tooling allows you to specify your build in terms of flavors. Because again, it's a complicated domain than building a jar. I have code that's in my free version, code that's in my paid version, code that's in my x86 version, etc. And the question is there a different way to lay those things out? The fundamental answer is yes. Just in the same way that you can specify the main set of source lives in source main Java. With the Android model, you can say that the free source set, its source code lives in source free Java, but also lives in source common Java. And this other flavor lives there as well. So you have all that same kind of configurability to do that. I would suggest asking about that on the ADT dev list from the Android experts. Give some good help on that. Yeah.
All right. So with that, thank you, Luke.
Thank you.